Good afternoon, students. So last class we started discussing the types of quadrilaterals and properties. We're going to continue. So first type of quadrilateral that we are going to discuss is trapezium. So what is trapezium? In American English it is called trapezoid. So what is trapezium? A parallelogram. It's a quadrilateral in which one pair of opposite sides are parallel. That is called a trapezium. Let's take this is a quadrilateral and we have one pair of opposite sides are parallel. So these two arrow marks indicate that they are parallel. So in this quadrilateral ABCD, we have AB parallel to CD. AB is parallel to CD. Then we can say this is a trapezium. So what are the properties that a trapezium will satisfy? You can see clearly that you can extend the lines to imagine. If these two lines are parallel and this is transversal, you can clearly see that this angle and this angle are co-interior angles. So if the lines are parallel, co-interior angles are supplementary. So we can say that first property, angle A plus angle D is going to be equal to 180 degrees. And similarly, these two also co-interior angles, this one and this one. So how you can imagine these two parallel lines and this is a transversal, and B and C are going to become co-interior angles for parallel lines. So if the lines are parallel, co-interior angles are supplementary. You can say B plus C is also equal to 180 degrees. So this is the property. And moreover, about trapezium, what you can say is all the properties of quadrilateral will apply here. The number of diagonals is 2, and sum of all the interior angles is equal to 360 degrees, everything. So this is about trapezium, and the important property in your syllabus is the co-interior angles aligned to parallel lines are supplementary. Okay, so this is about trapezium. And next we discuss about parallelogram. What is parallelogram? It is a quadrilateral in which two pairs of opposite sides are parallel. So in trapezium, it is sufficient to have only one pair, but in parallelogram, we need two pairs of opposite sides parallel to call it as a parallelogram. So let's take this example. ABCD is a quadrilateral in which AB is parallel to CD and AD is parallel to BC. So you can write in the definition that AB is parallel to CD is given and also AD is parallel to BC is given. Then we can call this as a parallelogram. And we use a symbol for parallelogram. We use this parallel and write GM. So this indicate parallelogram ABCD. So in parallelogram, what are the properties we have? So in the same case of trapezium, adjacent angles are supplementary because these two lines are parallel and this is transversal. These two are supplementary. And similarly, these two lines are parallel and this is transversal. So these two also supplementary. Like that, any two angles you take in the parallelogram, adjacent angles, they are always aligned to the parallel lines. So they are supplementary. So what we can write the first property, that any two adjacent angles you can take. Adjacent angles are supplementary. So how many pairs of adjacent angles are you going to get? Angle A, angle B, also angle B, angle C, and also angle C, angle D, and also angle D, angle A. You take any two adjacent angles, they always add up to 180 degrees. And next property we can have in parallelogram is opposite angles are equal. Opposite angles are equal. So the proofs of all these properties are going to be using congruency of triangles, which is not there in your syllabus, but using congruency, which you are going to learn in 6th and 7th classes. So there you are going to discuss the proofs, but without proofs, you just remember opposite angles are equal. So we can say angle A is equal to angle C. Let's use same number of strikes. And similarly, we can have angle B is equal to angle D. So opposite angles are going to be equal. And what about opposite sides? Opposite sides also equal. Opposite sides are equal in length. So we can say that AB is opposite to CD, their lengths are equal. And also we can say that BC is equal to AD, they are also opposite. Okay, so these two are equal. Let me write more properties here. Okay, next property that what we can write is fourth one, that is opposite sides are equal. And after that, something about the diagonals. Okay, diagonals bisect each other. Diagonals bisect each other. So what do you mean by diagonals bisect each other? You take the diagonal AC and also you take the diagonal BD. So they intersected a point O such that OD will be equal to OB and AO will be equal to OC. That means each diagonal is going to divide the other diagonal into two equal parts. So we can say AO is equal to OC, and also we can say BO is equal to OD. So this is about adjacent angles, opposite sides, and diagonals bisect each other. Okay. So this is about parallelogram properties. So students, any doubts in trapezium and parallelogram? You can raise a hand. Yes, students, any doubts in first two figures? Ashok, do you have any doubts?
Sir,
Yes.
explain trapezium.
Trapezium, one pair of opposite sides are parallel. So you can see AB is parallel to CD, but we don't know BC parallel to AD or not. So in trapezium, we have only one property. Thus, adjacent angles aligned to parallel lines are supplementary.
Sir, parallelogram.
In parallelogram, two pairs are parallel. AB parallel to CD and BC parallel to AD. So whenever parallelogram is there, it always satisfies these conditions. Adjacent angles are supplementary, opposite angles are equal, opposite sides are equal, and diagonals bisect each other.
Sir, parallelogram sum of angles total how much is it?
Yeah, every parallelogram is a quadrilateral, no? That's why it satisfies all the properties of quadrilateral. Automatically, sum of interior angles is going to be 360 degrees. Okay?
360.
Yes, 360 only. Because every parallelogram is a quadrilateral, no? And next type we are going to discuss is rectangle. So what is rectangle? You can say it is a parallelogram having one right angle. If a parallelogram has one right angle, automatically all the other angles become right angle. So you can see this is a rectangle. See, first of all, it is a parallelogram. One pair of opposite sides and second pair of opposite sides are parallel. So it is A, B, C, D. So what you know? You know that AB is parallel to CD, and you also know that AD is parallel to BC, and you also know that any one angle you can take 90 degrees. Suppose if I take angle A is 90 degrees, automatically angle B also become 90 degrees because adjacent angles of a parallelogram are supplementary. So what is the supplement of 90 degrees? 90 degrees only. If A is 90, its opposite angle C will be 90 because in parallelogram, opposite angles are equal. Similarly, B is 90, D will also be 90. So we can write here 90. So if one angle become 90 degrees, all the other angles also become 90 degrees. We can write A, B, C, D. All are going to be equal to 90 degrees. So this is the definition of a rectangle. It is a parallelogram having one right angle. So what are the properties of rectangle? So first let me write number one. Because every rectangle is a parallelogram, I need not write all the properties of parallelogram here. We can say all the properties, all the properties of parallelogram will be listed here. That means whatever the properties we discussed for parallelogram will be satisfied by rectangle also. Why? Because every rectangle is a parallelogram. So what are the properties we discussed for parallelogram? We discussed adjacent angles are supplementary. You can see in rectangle also any two adjacent angles are supplementary, and you can see opposite angles are equal. Yes, and you can see opposite sides also equal. AB measure will be equal to CD, BC will be equal to AD, and also you can see the diagonals bisect each other. If you draw the diagonals AC and BD, so every diagonal bisects the other diagonal. That means AO will be equal to CO and BO will be equal to OD. So need not write all the properties of parallelogram. We just wrote all the properties of parallelogram will be satisfied. And from number 2 will continue because rectangle satisfies some extra properties than parallelogram. What are they? So in parallelogram, we didn't see that the diagonals having equal measure. But in rectangle, the diagonals are always equal. Diagonals are equal. And you can see in rectangle all the angles are 90 degrees, but in parallelogram maybe or may not be. Okay, so that you can remember diagonals are equal. So what we can say from this, you can say I'm sorry, the diagonal name is AC will be equal to BD. Okay, and we already know that the diagonals bisect each other, so you can say BO equal to OD and AO equal to OC. Because the diagonals are equal, all four parts will be equal. AO will be equal to BO will be equal to CO and DO. All the four parts will be equal because the diagonals are having equal length and they are divided into two equal parts. And next, let us discuss rhombus. After that, I'll open for doubts. So, what is rhombus? Rhombus also can be defined from a parallelogram. A parallelogram having adjacent sides equal. In parallelogram, adjacent sides may not be equal, but if you maintain adjacent sides are equal, it's going to become a parallelogram. So let me draw a parallelogram here. Yes, it is a parallelogram only, but adjacent sides also equal. Let us say this is A, B, C, D. So DC is parallel to AB and DA is parallel to CB. And what happened? Two adjacent sides became equal. Whenever two adjacent sides are equal, automatically all are equal. Why? Because opposite sides are equal in parallelogram. If any two adjacent are equal, all the sides are going to be equal. So you can say in rhombus, all sides are going to be equal. So what are the definitions from rhombus we can write? So first of all, we know AB is parallel to DC, and then we know AD is parallel to BC, and then we know all the sides are going to be equal. That is, AB will be equal to BC will be equal to CD will be equal to DA. Then it's going to become a rhombus. So now what are the properties of rhombus? The properties of rhombus are, again we can list all the properties of parallelogram here. All the properties of parallelogram. Why? Because every rhombus is a parallelogram. So what are the properties of parallelogram we discussed? Opposite angles are equal, adjacent angles are supplementary, opposite sides are equal, and diagonals bisect each other. Everything will be satisfied here. You can check adjacent angles, you take these two, they are supplementary. These two, they are supplementary, and BA, they are supplementary. AD, they are also supplementary. So adjacent angles are supplementary, and you can check opposite angles are equal. A will be equal to C, and also B will be equal to D. So you need not write the properties again. You just copy from parallelogram. That is, all the properties of parallelogram will be satisfied by rhombus also, because every rhombus is a parallelogram. And diagonals also bisect each other. You can take AC is a diagonal. You take AC is a diagonal, and you can take BD is a diagonal. They also bisect each other. Okay, that means if this point is O, DO will be equal to OB, and OC will be equal to AO. But moreover, you can see one extra property of rhombus, that is the angle between the diagonals is going to be 90 degrees. So we can say diagonals are perpendicular to each other. Diagonals are perpendicular to each other. You cannot see this in parallelogram. In parallelogram, the angle between diagonals may be 90 degrees or not, but in rhombus, the angle between diagonals will be exactly equal to 90 degrees. So any doubts till rectangle and rhombus also, you can ask now. Any doubts still here? Nishika, you have any doubts? Nishika?
Sir,
Yes, Nishika?
sir, I have doubt.
Tell me.
Sir, in rectangle.
Okay, what is your doubt in rectangle?
Yes, sir.
What is your doubt in rectangle?
Sir, AB.
AB is parallel to CD. Parallel means what? Even if you extend them, they are not going to intersect. Okay?
Okay, sir.
Ashwin, what is your doubt?
Sir, my doubt in rhombus, sir. Rhombus.
Okay. Tell me.
Sir, rhombus and parallelogram are different shapes, sir.
Every rhombus is a parallelogram, but every parallelogram need not be rhombus. See, in rhombus, opposite sides are parallel and also all sides are equal. But in parallelogram, you can say only opposite sides are parallel, but all the sides may not be equal. Only you have opposite sides are equal in parallelogram, but adjacent sides you don't know.
Sir, parallelogram is a square.
Every square is a parallelogram, but every parallelogram need not be square. Square we are going to discuss next.
Okay, sir.
So next figure is going to be square. Square we can define in two different ways. Okay, either we can define it from rectangle or we can also define it from rhombus. Okay, let's discuss about square now. Square we can give two definitions. Either we can say it is a rectangle in which adjacent sides are equal. We know that in rectangle adjacent sides may not be equal, but if adjacent sides are equal, then it is going to become a square. Or we can also define it from a rhombus. A rhombus in which one angle is right. In which one angle is right. In rhombus, there is no condition that every angle must be right angle, but if any one angle become right angle, all the other become right angle and becomes a square. So square is like this. It can be achieved from rectangle and also rhombus. How to make a rectangle a square? You make adjacent sides are equal, it's going to become a square. How to make a rhombus a square? In rhombus, all the angles may not be 90 degrees, but if you make one angle 90 degrees, automatically all of them is going to become 90 degrees. So let us say ABCD. So first of all, what are observed in the square? We know opposite sides are parallel. So we can say AB is parallel to CD, and also we can say BC is parallel to AD. So opposite sides became parallel. Then we said adjacent sides are equal. That means AB equal to BC equal to CD equal to DA. So any two adjacent sides you take, they are equal. Automatically all of them will become equal. CD equal to DA. And then at least one angle you take right. If angle A is 90 degrees, automatically B becomes 90, C become 90, and D also become 90. So we can write angle A equal to angle B equal to angle C equal to angle D, and all are equal to 90 degrees. So this is the definition of a square. So properties, you need not write all the properties of square. So every property discussed before this is going to be there in square, because we can say every square, okay, you can write otherwise all the parallelogram properties, rectangle properties, and rhombus properties. So you can list out all the properties of parallelogram, rectangle, and rhombus. So let us check why it is satisfied, because every square is a parallelogram, every square is a rectangle, and every square is a rhombus. First, let us check parallelogram properties. Opposite sides are parallel and diagonals bisect each other. You can take in square also the diagonals, you can check the bisect each other. If you take this point O, AO will be equal to OC, BO will be equal to OD. And like in rectangle, the diagonals are equal. You can see AC length is equal to BD length. Okay. And in rhombus, we know the angle between diagonals is 90 degrees. So in square also the angle between diagonals is going to be 90 degrees. That means whatever property you know from parallelogram, rectangle, and rhombus, it will be satisfied by square. So what are the examples of such properties? Diagonals bisect each other, diagonals are perpendicular to each other, diagonals lengths are equal, adjacent angles are supplementary, opposite angles are equal, opposite sides are equal, adjacent sides are equal. Everything will be satisfied in square. Okay. So till square, any doubts you can raise a hand. Till square, you have any doubts? So we discussed today trapezium, parallelogram, rectangle, rhombus, and square and their properties. So any doubts you can raise a hand. Yes, Harshvardhan?
Sir, why it is satisfying all properties?
Because it is defined like that. We defined the square as a rectangle in which all sides are equal. That means before becoming a square, it was rectangle first. That's why it's carrying all the properties of square,
Sir,
rectangle,
sir,
and
sir,
similarly rhombus.
sir, we can call a square as a rhombus because it is 90.
Yeah, every square is a rhombus, but every rhombus need not be square. Okay,
Sir, every rhombus did not miss square means, sir.
that means you take only a rhombus where it 90 degrees is not observed in any angle. That is only a rhombus, but not a square, right?
Sir, why?
See, I'm going back to this figure. So you can see this figure here,
Yes, sir.
this one.
Yes,
Is this
sir.
a rhombus?
Yes, sir.
But is this a square?
Sir, no.
Why? Because in square all angles must be 90 degrees, no?
Yes, sir.
So that's why it is not a square. See, every square is a rhombus, but every rhombus need not be a square. Jashvi, what is your doubt? Jashvi?
Sir, can you explain square?
See, square we can define from two figures like rectangle and rhombus. In rectangle, do you think adjacent sides are equal?
Yes, sir.
Maybe, may not be. But if they are equal, it becomes a square also. Okay.
Oh,
So a rectangle in which adjacent sides are equal, it becomes a square. Or we can also define it from a rhombus also. In a rhombus, every angle may not be 90 degrees. But if 90 degrees becomes, then the rhombus becomes a square. So we can define square like a rhombus in which one angle is right. Automatically, all of them become right and becomes a square.
okay, sir.
Manaswini, what is your doubt? Manaswini? Manaswini, you're not audible.
Sir,
What is your doubt?
sir, I didn't understood trapezium.
Trapezium means only one pair of opposite sides are parallel. Okay. The other opposite side we don't know. Okay. For example,
Yes, sir.
ABCD quadrilateral is there. AB is opposite to CD, right?
Yes, sir.
So AB is parallel to CD. Only we know that thing, and any other information is not there. So we can say it is a trapezium. Okay.
Sir, I have also doubt of rhombus, sir.
Okay. Rambus, what is your doubt?
Sir, I didn't understand rhombus properties.
See, rhombus is like a parallelogram only, but in parallelogram, all sides may not be equal, right?
Yes, sir.
But if adjacent sides become equal, automatically all the sides become equal. Then it becomes a rhombus. That means rhombus means what? It is a parallelogram having all sides are equal. That's it.
Okay, sir.
Okay. In that we have an extra property that diagonals are at right angle to each other. That means the angle between diagonals is going to be 90 degrees. So after square, some special types of quadrilaterals that we are going to discuss. Like in trapezium, there is a special type called isosceles trapezium. Isosceles trapezium. Manasvi, you can mute yourself. It is a trapezium only. It is a trapezium. Like let us say A, B, C, D is there. You know AB is parallel to CD. Yes, it is a trapezium. One more condition is that the non-parallel sides must be equal. That means AD will be equal to BC. So then we can say it is an isosceles trapezium. In normal trapezium, this second condition is not there. The non-parallel side should be equal. It's not there. Maybe or may not be. But in isosceles trapezium, first of all, it is a trapezium. One pair of opposite sides are parallel and non-parallel sides also equal. So we can say AB is parallel to DC and also AD length is equal to BC length. Then it is going to become an isosceles trapezium. And what are the properties? See, because every isosceles trapezium is a quadrilateral, all the quadrilateral properties are going to be there. Sum of interior angles 360 degrees, number of diagonals is 2. And because every isosceles trapezium is a trapezium, and trapezium property is also satisfied. So what is the first property? That is angle A, angle D. They are aligned to the parallel lines. So we can say angle A plus angle D is going to be 180 degrees. They are supplementary. And similarly, angle B and angle C also supplementary because they are aligned to the parallel lines. So this property we understood from trapezium only. In trapezium also, the adjacent angles aligned to parallel lines are supplementary. So because every isosceles trapezium is a trapezium, it also satisfies that property. And some extra properties are there for isosceles trapezium. That is, the lengths of the diagonals are going to be equal. So AC will be equal to BD. So we can write the length of AC will be equal to length of BD. And next property is going to be base angles are going to be equal. Like you can say angle A, angle B, they are going to be equal. And similarly the other pair also, like angle C and angle D, they are also going to be equal. So these are the extra properties that isosceles trapezium is satisfying. So what is isosceles trapezium? It is a trapezium in which non-parallel sides are equal. Then it is going to become an isosceles trapezium. Some other types of quadrilaterals also there. They are, after isosceles trapezium, we have kite. Let's take a kite. So what is kite? It is a quadrilateral. It is a quadrilateral in which two pairs of adjacent sides are equal. Let's take, this is the figure. A, B, C, D. So you can see AB and AD, they are adjacent sides and they are equal. BC and CD, they are also adjacent sides and they are equal. Then we can say this quadrilateral as a kite. So in kite, what are the conditions? AB will be equal to AD and CB will be equal to CD. So two pairs of adjacent sides are equal, then it's going to become a kite. So what are the properties of kite? So because every kite is a quadrilateral, it satisfies all the properties of quadrilateral. Sum of all the angles is 360 degrees and number of diagonals is 2. Other than that, it is satisfying some more properties that, so you can see if you draw AC one diagonal and BD one diagonal, they are at right angle to each other. So we can say AC is perpendicular to BD. Okay, AC is perpendicular to BD. So this kind of property is observed in rhombus and square. You can see that the angle between diagonals is 90 degrees and it is also seen in kite. And next property is if you take the point of intersection is O, that is the diagonals are intersecting at O. So in parallelogram we saw both diagonals, they bisect each other, but here only one diagonal bisects the other. So you can see AC is vertical and BD is horizontal. The vertical diagonal is bisecting horizontal diagonal. That means we can say DO is equal to BO, but we don't know the other part AO is equal to OC or not. So we can write DO is equal to OB. That means the vertical diagonal is going to bisect the horizontal diagonal. And one more property, that is it is going to bisect the angles, like angle A and angle C is going to bisect. So we can say angle DAC is equal to angle BAC, and also we can say angle DCA is equal to angle BCA. Such property is observed in rhombus also. In rhombus also, you draw diagonal, it is going to bisect the angle where it is drawn. Okay, and these are the properties of kite. Okay, and one more type of quadrilateral is, and you remember kite is also called deltoid in British English. And the next type of quadrilateral is arrowhead. Before discussing arrowhead, one more point about kite is every rhombus is a kite, but every kite need not be a rhombus. That's why rhombus satisfies all the properties of kite. Next, arrowhead. Arrowhead means it is also a kite. It is a kite in which one angle is reflex. That means more than 180 degrees. One angle is reflex. So how is it going to look like? It's going to look like this. It's like the head of an arrow. Okay, as you can see, this is A, B, C, D. You can see AB is equal to AD, and you can see BC is equal to CD. So what we can write? AB is equal to AD and BC is equal to CD. So it became a kite. And you can see one angle is more than 180 degrees. Okay, we can say angle BCD is going to be greater than 180 degrees. Okay, so that's why it is a reflex angle. So this type of quadrilateral is called kite. Arrowhead. It is a kite, and one angle is more than 180 degrees. So what are the properties it's having? So because every arrowhead is a kite, it satisfies all the properties of kite, and moreover, we can say one diagonal lies in the exterior. So till now, whatever quadrilaterals we discussed, all the diagonals are lying in the interior, but here one diagonal is lying in the exterior. You can see. So AC is a diagonal; it's lying in the interior, but you can see the diagonal BD. It's lying in the exterior of the quadrilateral. So you can see this is the interior part of the quadrilateral, but it is lying in the exterior. Okay, so one diagonal lies in the exterior of the quadrilateral. So these are all the types of quadrilateral that you need to remember. Any doubts still here you can ask. Then we are going to start discussing the problems related to the properties of quadrilateral. Manaswini, any doubts? Manaswini?
Sir, I have a doubt. Isosceles trapezium.
Isosceles trapezium means it is also a trapezium, but in which the non-parallel sides are equal. See, in trapezium, we have only one pair of opposite sides are parallel, and other pair we don't know. So if the non-parallel
Yes, sir.
sides are becoming equal, then it is going to be called isosceles trapezium. That's it. Okay. And
Okay,
what are
sir.
the properties it is satisfying? The adjacent angles aligned to the parallel lines are supplementary. AD are supplementary, BC are supplementary. And diagonals are
Mm.
having equal length. You can see AC diagonal is equal to BD diagonal length. And you can also
Yes,
see
sir.
the base angles are equal. Angle A equal to angle B and angle C equal to angle D. Manaswini, what
Okay,
is
sir.
your specific doubt?
Sir,
Any other doubt you have?
sir, I has a doubt. This last one, sir, I cannot say this. Pardon,
Which one?
sir.
Arrowhead.
Sir, yes, sir.
What is your doubt in arrowhead?
Sir, I didn't understood arrowhead's properties.
See, arrowhead means it is also a kite. What do you mean by kite? Two pairs of adjacent sides must be equal. So you can see
Equal,
the
sir.
length of AB and length of AD. Are they equal?
Yes, sir.
And similarly, the length of BC and length of CD, are they equal?
Yes, sir.
So two pairs of adjacent sides are equal. And one more condition is that one angle should be more than 180 degrees. Your angle BCD is more than 180 degrees or not?
Yes, sir.
So that means it is satisfying all the conditions in the definition. That is, two pairs of adjacent sides are equal and one angle is reflex. Then it is called an arrowhead. Only in this type of quadrilateral, we have one diagonal is lying in the exterior. If one angle is more than 180 degrees, definitely one diagonal goes to the exterior.
Okay, sir.
Jashvi, what is your doubt?
Sir, I had
Yes,
doubt in kite properties.
kite properties. Okay, what do you mean by kite? You understood the definition?
Yes, sir.
What is kite? It is a quadrilateral in which two pairs of opposite sides, adjacent sides are equal. So we can say ABAD equal length, BCCD equal length. Now the first property is if you draw the diagonals, what is the angle between diagonals you are observing, Jashvi?
Sir, what, sir?
Angle between the diagonals.
Diagonals.
This angle between the diagonals is 90 degrees, isn't it?
Ah, yes, sir.
That's why we can write that they are perpendicular to each other. AC and BD are perpendicular to each other. So the diagonals are perpendicular to each other in this. And what is another quadrilateral? We have the same property. In rhombus also they are perpendicular to each other, and in square also they are perpendicular to each other, right?
Yes, sir.
So in which type of quadrilaterals we have the diagonals perpendicular? Square, rhombus, and kite. And even arrowhead also they are perpendicular, because every arrowhead is a kite. You can produce this diagonal down, so you can see the right angle here. Okay.
Okay, sir.
And in kite, the other property is one diagonal bisect the other diagonal. You can see the DO length is equal to OB length.
Yes, sir.
And also the vertical diagonal bisects the angle through which it is drawn. That means this angle is bisected. Bisected means two equal parts. And this angle is also bisected by the diagonal. Two equal parts it's going to divide. Okay, Jashvi?
Sir,
Yes.
sir, what is this? AC, what is it?
AC perpendicular to, that is a symbol for perpendicular to.
Okay, sir.
What is perpendicular to? That is, if the angle between two lines is 90 degrees, we use this symbol. AC is perpendicular to BD. That means the angle between them is 90 degrees. Okay.
Okay, sir.
Mayuk, what is your doubt? Mayuk?
Sir, I have a doubt.
Yes.
So we can fly arrowhead shaped kite also.
Yeah, every arrowhead is a kite, because arrowhead is different from kite only. A kite in which one angle is reflex, that is called arrowhead. Okay.
Sir, we can fly one arrowhead shaped kite also.
Yes, you can do that. Even the boomerangs are in the shape of arrowhead only.
Oh, okay.
Ashardan?
Sir,
Yes.
sir, why you said the arrowhead is a kite?
Because arrowhead is defined from kite only. It is a kite in which one angle is reflex is becoming arrowhead. That's it.
Sir, one diagonal lies in the exterior means.
Yeah, you try to join B and D. The BD diagonal is lying outside the figure or inside the figure.
Sir, outside.
That's why it is in the exterior. Okay.
Sir, it is called a quadrilateral when diagonal is in exterior.
Yeah, we can say that at least one angle is more than 180 degrees. Then definitely one diagonal should go outside. Okay.
Okay.
Abhyuday?
Sir, I didn't understand isosceles trapezium.
Isosceles trapezium means it is also a trapezium, but non-parallel sides are equal. See how a normal trapezium look like. A normal trapezium may look like this. Okay, so you can see this is parallel to this. In ABCD, AB is parallel to CD. But do you think AD and BC lengths are equal? Do you think they are equal?
No, sir.
No, BC is looking longer, right?
Yes, sir.
But in isosceles trapezium, AD and BC are going to be equal. Is it clear?
Yes, sir.
Okay. And it satisfies all the properties of trapezium. And extra property is that the diagonals are going to be equal and base angles are also going to be equal. Okay.
Sir,
Yes, Abhyuday?
sir, why did you put the two lines with A and B?
That is a parallel symbol, no? AB is
Sir,
parallel to DC.
sir, here on the diagonal.
On the diagonal, that is angles. Two angles are equal. Angle A and angle B are equal. So say that those two angles are equal.
Okay, sir.
And Rishika, what is your doubt?
Sir,
Yes.
sir, I didn't understand the rhombus properties.
Rhombus properties. See, let's go back to rhombus. Yes, rhombus is here. What is rhombus, Rishika? It is a parallelogram having adjacent sides are equal. Okay.
Oh.
If any two adjacent sides are equal in parallelogram, automatically all of them will become equal. Because in parallelogram, we know opposite sides are equal, right?
Yes, sir.
So if adjacent sides are equal, definitely all of them are going to become equal.
Okay.
Okay, now what are the properties here? Every property of parallelogram will come into rhombus. Why? Because every rhombus is a parallelogram. Why? Because rhombus we define from parallelogram only, right?
Yes, sir.
So what are the properties of parallelogram? We have the diagonals bisect each other, opposite sides are equal, opposite angles are equal, adjacent angles are supplementary. Everything will be satisfied in rhombus. But some extra property is there in rhombus, that is the diagonals are perpendicular to each other. We can add one more property also here, that is diagonal bisect the angle, diagonal bisect the angle through which it is drawn. Diagonal bisect the angle through which it is drawn. So you can see I can take the diagonal AC. Okay, AC is drawn through which two angles? Angle A and angle C. That means this angle and this angle is going to be equal, and this angle and this angle is going to be equal. And similarly with the BD also. So wherever you draw the diagonal, the angle will be bisected in rhombus. Okay.
Okay, sir.
Okay, so these are the properties and types of all the quadrilaterals and their properties. Now, based on these properties, we have some questions. This question came in 2020 paper. Okay, so all of you try to solve this. A photo frame is in the shape of a quadrilateral with one diagonal longer than the other. Which of the following is a possible shape of the photo frame? Is it a square? Is it a rectangle? Is it a rhombus? Or none of this? Who is going to answer this question? Raise a hand if you want to answer. Vishnu, can you read the question again? Vishnu? Vishnu, you're not audible. Sriyash, can you read the question?
Sir,
Yes.
a photo frame is in the shape of quadrilateral with one diagonal longer than the other. Which of the following is the possible shape of the photo frame?
Yes. What do you think?
The rhombus.
Okay, why not square?
Sir, because two diagonals are equal, sir, in square.
Very good. So square we have eliminated because in square two diagonals length will be equal. And what about rectangle?
Sir, rectangle also two diagonals are equal in
That's
length,
right.
sir.
This is also eliminated. But in rhombus,
Sir, one is smaller and one is bigger, sir.
may be equal, may not be equal. We don't know. Okay, we cannot decide because in rhombus, if the diagonals become equal, it may become square also. But possibility is there or not because they are asking possible shape. Rhombus is possible or not?
Yes, sir.
Yes, you take a rhombus, you can see one diagonal longer and one diagonal shorter is possible. You can see the vertical diagonal is longer and the horizontal diagonal is shorter. So the possible figure in this is option C. Okay, very good,
Sir,
Sriyash.
sir,
Yes,
majority is to kite na, sir, this question answer.
come again.
Sir, the majority answer is kite na, sir.
See, the for the question we need to answer. Okay, what they said, what is the possible shape, and the possible shape is there in one of the options. Yes or no? We have to go for rhombus. Don't think about anything else. What is their question? They're asked which of the shape is possible. Is rhombus possible or not?
Yes, sir.
If kite is there, then it creates the confusion. Suppose if I give in place of square, I give kite, then both there, and in option D, I'm going to say both A and C. You understand?
Okay, sir.
Depending on option also, we can change the final option like both A and B or none of this like this. So for this question, C is correct. Okay. But as you said in kite also, the lengths of the diagonals may be not equal. Okay, in rhombus, one is longer and another is shorter. So next question came in 2018 exam based on types of quadrilaterals and the properties. Which of the following statements is true? All hexagons are triangles because they have at least three sides. All octagons are polygons because they have at least three sides. All parallelograms are rectangles because they have two sets of parallel sides. All rhombuses are squares because they have four sides that are all the having same length. Okay, who is going to answer this question? Raise a hand. You have to identify the true statement. Yes, Danvir, can you read the question again? Danvir,
Sir, option B, sir.
read the question first. From the beginning. Then we read the question from the beginning. Rishika, can you read the question from the beginning? Rishika?
Hello.
Rishika, read the question from the beginning. What happened? Abhiday.
Sir,
Yeah, read the question.
all hexagons are parallel because they have at least 3 sides.
What do you think about option A? True or false?
Sir, false.
Why is it false?
Sir, hexagon has 6 sides.
Yeah, they are saying all hexagons are triangles. It is false because hexagon must be having 6 sides, but triangle cannot have that. So option A is false. So who is going to discuss about option B? Harshavardhan, read option B.
All octagons are polygons because they have at least 3 sides. Sir, correct, sir.
Okay, what do you mean by octagon?
Sir, it having 10 sides, sir.
Octagon means 8 sides.
Sir, 8 or 8
Yes,
sides.
decagon means 10. Yeah, they're saying all octagons are polygons because they have at least 3 sides. So
Yes,
at least 3 means 8 is satisfied.
Yes.
At least 3 means 3 or more. So 8 is there in the list of 3 or more. Yes. And to create a polygon, minimum how many sides are required?
Sir, 3 sides.
Yeah, that's why it is true. So every octagon can be called a polygon.
Sir,
Okay. Even though we got the answer in option B, we need to check C and D. Manaswini, can you read option C? Manaswini,
Sir,
read option C.
sir,
Read option C.
all parallelograms are rectangles because they have 2 sets of parallel sides.
What do you think, true or false?
Sir, true, sir.
Why true? Can you explain?
Sir, sorry, sir, wrong, false.
Why false? Can you explain?
Sir, because the parallelogram has two sides, two
They are
sets of.
saying that all parallelograms are rectangles, okay, and they're giving reason also because they have 2 sets of parallel sides. To call rectangle,
Yes.
the condition 2 sets of parallel sides is sufficient or not sufficient?
Sir, sufficient.
Not sufficient. We want one more extra reason, that is one angle should be 90 degrees, then only it become rectangle. Yes.
Okay. Yes, sir.
And the statement also they said is wrong because all parallelograms need not be rectangle. But the converse is true. You can say every rectangle is a parallelogram, right?
Yes, sir.
This is false. Give correct reason, Manaswini. Think before answering. Amshuman, can you read the option D? Amshuman, can you read option D?
Sir, yes, sir. Sir, all the rhombus are square because they have 4 sides that are of the same length.
True or false?
Sir, false.
Why? Can you explain?
Sir, because of in square every angle is 90 degrees, but
Very
in
good.
rhomb not 90 degrees. Sir.
Very good. Because they did not give the condition that all the angles are 90 degrees. They said only they have 4 sides that are all having equal length. Inside also 4 sides are having equal length. In rhombus also we are having. But the condition, one more condition is not given to become square. That is every angle must be 90 degrees. So saying all rhombuses are squares, true or false?
Sir,
Saying all rhombuses are squares, true or false?
sir, false.
What about the converse? All squares are rhombuses.
Sir,
What about the converse? That is all squares are rhombuses. Can I say that?
true, sir.
That is true. So in this given options, the only correct option is B. Okay, Amshman, you can mute. B is the true statement. So next question on the properties of quadrilateral we have in the same year 2018 paper. So which two quadrilaterals have both two pairs of parallel sides and two acute angles? So there are two conditions given. You should have two pairs of parallel sides and you should have two acute angles. Who's going to answer this? Vishnu, can you read the question? Vishnu, read the question.
Which two quadrilaterals have two pairs of parallel and two acute angles?
Okay, go option by option. In option A, which shapes do you see?
Sir, square and trapezium.
Okay, in both the figures, do you see two pairs of parallel sides?
Sir, the second figure doesn't have two pairs of parallel sides.
Very good. It has only one pair. So can I eliminate option A?
Yes, sir.
Okay, what about option B?
Sir, both of them have two pairs
Vishnu,
of parallel.
Vishnu, in the background, I'm listening to some voices. Can you move away?
Sir, actually, I am.
Okay, no issue. Go ahead. Complete this.
Sir, option B, both of them have two pairs of parallel sides.
Okay. What about the second condition?
Sir, no, sir, because rectangle doesn't have two acute angles.
So even can I eliminate option B?
Yes, sir.
Yes. What about option C? First of all, in option C, what are those two shapes?
Sir, parallelogram and the rhombus.
Okay. These two shapes are satisfying those two conditions.
Sir.
Okay. In both the shapes, do you see two pairs of parallel sides?
Yes, sir.
And two acute angles are also there.
Yes, sir.
Okay. Tell me which type of angle is this?
Sir, acute.
Okay. Which type of angle is this?
Acute.
Okay. Which type of angle is this?
Acute.
Okay. Which type of angle is this?
Sir, acute.
So we have two acute angles here. And what about rhombus? This is obtuse or acute?
Sir, acute.
What about this?
Acute.
So this is acute and this is acute. So you can see in option C, we have one pair of opposite sides parallel, second pair of opposite sides parallel. Even in rhombus, one pair of opposite sides are parallel, second pair. So now can we go for option C here, correct answer?
Yes, sir.
Okay, but you should tell me in option D, why it is wrong option.
Sir, because the trapezium doesn't have two pairs of parallel sides.
Very good. So all are eliminated except option C. So the correct answer for this is going to be C. Okay. Very good, Vishnu. You can mute now. So next question from the properties of quadrilaterals came in 2017 descriptive exam for 3 marks. Two angles of a quadrilateral are each 90 degrees and remaining two angles are such that one is 3 times the other. Find these two angles. So who is going to solve this question? Two angles of a quadrilateral are each 90 degrees and remaining two angles are such that one is 3 times the other. Find these two other angles. Who is going to answer this? Mayuk, read the question again.
Two angles of quadrilateral are each 90 degrees and remaining two angles such that one is the three times the another.
Okay, how can we solve this?
Sir, one angle is 90 degrees.
Okay, 90 degrees. Next. What
Sir,
happened?
Sir, 2 or 90 degrees.
So I can write 90, 90.
Yes, sir.
What about the next two?
The remaining 2 are 3 times of the another. Sir, 3 times of the another 2 angles, sir. 1 angle is.
What is the third
And
angle? What is the fourth angle? Tell me.
sir, in third angle is 3. In third angle, 3 times of fourth angle.
What is third angle?
Sir, 3 times of fourth angle.
Okay, how can I write that? If you don't know, we can use any variable, no?
Yes, sir, x or xy.
Okay, you want to call third angle as x or fourth angle as x?
Sir, third angle is x.
Okay, if you call third angle is x, what is the fourth angle now?
Sir, y.
No need to call y. You can write in terms of x only because we have a condition.
Yes, sir. So 3x.
Yes, 3x. Now we have all the four angles of a quadrilateral. What do you know about the four angles of a quadrilateral?
Sir, sum of 4 angles are
360 degrees. Can I add all of them and make it equal to 360 degrees?
yes, sir.
From this, can't we find this angle and this angle now?
Yes, sir.
Let's try to simplify for
Sir,
the value of x.
sir, we have, sir, 90, we have to add 90, subtract 90 and 90.
Okay, you are transposing 90, 90 sum to the right side. And what is x plus 3x?
Sir, x plus 3 is 4x.
So you can write 4x. And on the right side, 360 degrees minus?
180 degrees.
What is 360 minus 180?
Sir, 180.
Okay, now I want the value of x. Yes, 180 divided by 4. Simplify this. Yes, what is the final answer?
Sir, 45.
Yes, 4 4s are 16, 4 5s are 20. This is x, we got 45. That means now we got the third angle. What is the third angle?
Sir, third angle, sir, 45.
45.
Sir,
And what is fourth angle?
sir, 45 into 3.
Yes, that is 3 into 45. What is 3 into 45, Mike? Very good. 45 and 135. Exactly, correct answer. Mike, very good. You gave the correct answer. 45 and 35 are the other two angles. Okay. So this is based on angle sum property of a quadrilateral. Sum of all the four angles is equal to 360 degrees. Using that, we found the next two angles, 45 and 135. So this is about types of quadrilaterals and their properties. And next we are going to discuss about circle and its parts. Okay. So first let us try to define what is circle. So what is circle? Circle means it is the set of all the points which are equidistant from a fixed point in a plane. So that set of points is called circle. You take this point O, okay, and let's take a point P here such that OP distance is 5 centimeter. Now, if I'm asking, is P the only position possible so that the distance is 5 centimeters? No, there are many more points possible. Here is also P position possible so that OP is 5 centimeter. Here also P position possible so that OP is 5 centimeter. Like that, you collect all the positions of P wherever the distance is 5 centimeter away from O. The collection of all those points is ultimately going to become circle. So what is circle definition? The set of all points which are equidistant from a fixed point. Equidistant means having same distance. The fixed point is called the center of the circle, and the fixed distance, okay, that is called radius of the circle. Okay, so generally center of a circle is denoted by the letter O, and radius of the circle is denoted by the small letter r. Okay, So next, let us discuss about different parts of the circle. Okay, and the curve is called the circumference. So different parts of a circle we are going to discuss. So first, diameter. So what is diameter? Okay, you take a radius and produce it to the other side to meet the circle. Okay, so this is called a diameter, denoted by the letter D. Okay, diameter is always 2 times the radius. In one diameter, how many radius are possible? 2 radii. Okay, radius singular, radii plural. Even it is useful for your English. Radius plural is radii. Okay, so this is diameter. And next we are going to discuss more terms in circle. Next we are going to discuss chord. So what is chord? So we have a circle. Take any 2 points. Let us say this is A and this is B. Okay. The join of these 2 points, or the line segment joining A and B, is called a chord. Okay. So chord, there is a property you need to remember. That is, as the chord is moving close to the center, the length of the chord is going to increase. As the chord is moving away from the center, the length of the chord is going to decrease. Okay. See, um, let's try to understand that. See, this is a circle and this is the center. I'm moving the card close to the center. Okay, this is AB. So you can observe the length of the card is increased. I'm moving it away from the center now. Okay, I'm moving away from the center. This A and this is B. So the length of the card is decreased. That means the length of the card depends on the distance from the center. If it is moving closer to the center, its length will increase. If it is moving away from the center, its length will decrease. And what is the maximum position possible for a card? That is, if it passes through the center. So card is going close to the center, and finally it is passing through the center. That is going to become diameter. So diameter is the final limit for the chord. It cannot cross more than diameter. That means we can say that the longest chord is nothing but the diameter of a circle. So you can observe every diameter is a chord, but every chord need not be a diameter. So that is about chord. And one more important property about chord is, if you drop a perpendicular from the center to the chord, it will always bisect it. Let's say this point is M, then AM is going to be equal to MB. So what is the property? Let us say this is O. Okay. If OM is drawn perpendicular to AB, that means a perpendicular is dropped from the center to a chord, then it is going to bisect it. That means AM is going to become equal to BM. Converse also true. That means first you select the midpoint of AB so that AM is equal to BM. Just connect O to M. Then you are going to get OM will be perpendicular to AB. So both are true. From the center, if you drop a perpendicular, it will bisect the chord. Or you select the midpoint of the chord or connect to the center, that line will be perpendicular to the chord. Both are true. So this is about chord. Okay. And next, after chord, we are going to discuss more parts of the circle. Next, we are going to discuss about arc. What is arc? Yeah, some people are raising hands. Let me complete all the parts, then I'm going to open for the doubts. So this is center O. Let's take a point A on the circumference and let's take a point B on the circumference. So I'm showing with an yellow color curve. Okay, the part of a circle, which is joining 2 points on the circle. So this part is called an arc. Okay, and suppose let us say this point is X and this point is Y. So arc which is passing through X, AXB, that means I'm talking about this arc, is called the minor arc. This is called the minor arc. And the arc which is passing through the point Y from A to Y to B, this is called the major arc. AYB, this is called the major arc. So minor arc means less than semicircle and major arc means more than semicircle. You know, semicircle means exactly 2 parts. So this is semicircular arc, this is semicircular arc. If any arc is less than semicircular arc, it is minor. If any arc is more than semicircular arc, it is major arc. So that is about the arc. And then let us discuss about sector. What is sector? Sector means you take a circle and this is center O. Let us take a radius OA. Let us take another radius OB. So the simple closed figure bounded by two radii and the included arc. So this simple closed region is called sector. It's like a piece in a pizza. Okay, sector. So generally it is compared with pizza pieces. So it is a sector. What is sector? It is enclosed or a simple closed figure enclosed by two radii and the included arc. So in sector also we have two types. Okay, minor sector and major sector. So the one which I am shaded here, that is minor sector, and the other one which is not shaded, it is major sector. It is major sector. And next part in a circle is segment we have. Okay. Next we're going to discuss about segments. So what is segment of a circle? You take a circle, just draw a card. Okay. So this is AB. So the one which I am shading now, this region, that is the part which is enclosed between a card and an arc is called a segment. If it is size is less than semicircle, it's going to be minor segment. And if its size is more than semicircle, it's going to be major segment. Now finally, we're going to discuss about the semicircle. Exactly half size of the circle. So what is semicircle? You take a circle and this is the center. Draw a diameter. Okay, diameter always divides into two equal parts, two equal sized shapes. This is a semicircle and this is also a semicircle. Both are semicircles. So every semicircle can be treated as a sector as well as a segment. Semicircle is treated as a sector as well as a segment. Why? Because you can see in semicircle we have two radii. The two parts of the diameter are nothing but the radii and the included arc. And segment. Now the diameter can be treated as a chord also. So the chord and the arc are together. It can be treated as segment. So which figure can be treated as both sector and segment? Semicircle. Okay, it is exactly half size of the circle. So am I missing anything? Center, radius, diameter, chord, minor arc, major arc, minor sector, major sector, minor segment, major segment, and semicircle. Yes. So these are all the parts about a circle. And you have any doubts in this parts of circle, you can raise a hand. Any doubts in circle parts? Kumar.
Sir,
Yes, what's your doubt?
sir, major arc that, sir,
Yes, yes, tell me.
sir, major sector, sir, major sector area is equals to minor sector minus, chichi.
Anshuman, Anshuman, you
Sir,
need not discuss area here about all the areas and perimeters. We have a separate chapter, mensuration. There we are going to discuss about everything. Okay. Here only
okay,
parts of the
sir.
circle. That's it.
Okay, sir.
Neeraj, you have any doubts? Neeraj, in these parts of the circle, whatever terms we discussed, any doubts you have? Neeraj?
Sir,
Yes. You have any doubts, Neeraj?
sir, segment.
Segment means you draw any card. Okay. So I have already shaded one part. Can you see that?
Yes, sir.
One card and one arc are enclosing that part. That is called segment. If its size is less than semicircle, it is minor segment. More than semicircle, it's major segment. That's it. Okay.
Okay, sir.
Jashvi. Jashvi, what is your doubt?
Sir, I have doubt in chord.
Chord. What is chord? Very simple. No, it is a line segment joining any 2 points on the circle. See, where is chord? Yes. Chord is here. So A and B are any 2 points on the circle. You just join them with a line segment. That line segment we call it chord, right?
Yes, sir.
That's it. Any other doubt?
Sir, nothing.
And Manaswini, what is your doubt? Manaswini,
Sir,
yes.
Sir, I have a doubt on arc, sir.
Arc means what? You take any 2 points on the circumference of the circle, and part of a circle, that is, it should pass through the circle on the circumference of the circle. That part we call it arc. Okay. Arcs are of two types: minor arc and major arc. Okay.
Sir, what do you mean by minor arc?
Minor arc means it is less than the bigger part. See, you take any 2 points on the circle, always they are divided into two parts. See, I have taken A and B. Okay. So this part
Yes, sir.
and this part, the smaller one is called minor arc, and the longer one is called the major arc. That's it. Okay.
Sir, what is mean by sector?
Sector means it is bounded by two radii. So you can see this is a radius, this is a radius, and this is the arc. So whenever a simple closed figure bounded by two radii and the included arc, then it is called sector. Okay.
Sir,
Any other doubts?
sir, last one that is what, sir?
Which one?
Sir, semicircle.
Divide the circle into two equal halves using a diameter, then it is called semicircle, each of them. Okay.
Okay, sir.
Vishnu?
Sir,
Yes, what is your doubt?
sir, is there an arc exactly the measure of a semicircle circumference?
Yes, that is
And
called
what?
that is called semicircular arc. As you can see at the bottom of the screen, this is what you're talking about, right? This arc length
Yes,
is
sir.
equal to semicircle circumference, and it is called semicircular arc. Okay.
Okay, sir.
Okay. And Harini, what is your doubt? Harini,
How can we measure a minor segment and major segment?
measure. What do you mean? Is it area or perimeter?
Sir, area.
Yeah, about area we're going to discuss in next chapter, ma. Segment area will be there in that next chapter. But anyhow, we ask now from circle area. Okay, you are going to do. You take a center here, let O, and let us join with A as well as B. Okay, so this part is a sector, right?
Yes, sir.
From sector area, if you remove this triangle area, then it will be the segment area only.
Yes, sir.
So that is how we are going to find in the next chapter. Okay.
Okay, sir.
Abhiday, what is your doubt? Abhiday, make it fast. More questions are waiting. Rishika, you're not audible.
Sir,
Yes, yes. Tell me.
sir, I didn't understand chord note.
Come again.
Sir, I didn't understand chord note.
Yeah, card note point, right?
Yes, sir.
See, card slowly it is moving close to the center. I told you that its length is increasing, right?
Yes, sir.
And whenever the card meets the center, the card passes to the center, then it becomes a diameter. That's it. So the longest card possible in a circle is its diameter only.
Yes, sir.
And the next one is, if you drop a perpendicular to any card, perpendicular means having right angle, right?
Yes, sir.
Okay. Now, if you draw a perpendicular onto the card, it is going to bisect it. Bisect means two equal parts. AM and MB, do you think that they are having equal length or not?
Yes, sir.
So converse also true. If you take the midpoint of the card and connect to the center, that will be perpendicular to the card. Both are true. Okay.
Okay, sir.
And Harshavardhan, what is your doubt? Harshavardhan.
Sir, is the sector length and segment length segment area and sector area is equal?
Area, perimeter, we are not going to discuss in
That's
this
not
chapter. Next chapter.
they're equal.
You are asking about sector and segment.
Yes, sir. What is
Both
the
are completely different, no? Both are different figures.
sir? How like sir? They are
You're asking about the curve length, right?
sir. Curved
Yes,
length.
they are nothing but same. They are arc only. Amshuman. Anshuman,
Sir,
yes, what's your doubt?
sir, sir, the screen is don't visible to me, sir.
Leave the class and join again.
Sir, it is visible, sir.
Okay, you have any doubts?
Sir, yes, sir.
Okay, now see, these are the parts of a circle that we discussed. So I recall once again: center, radius, diameter, arc, chord, sector, segment, and semicircle. So based on them, let's see some questions. This question came in 2023. Okay, so the question is: read the given statements and choose the right option. Statement A: all chords of a circle are diameters. Statement B: diameter is the longest chord of the circle. So depending on A, B, C, D, which one is correct, we have to choose. Who's going to answer this question? Shreyansh, read the question.
Read the given statements and choose the right option. Statement A. All chords of a circle are diameters. Statement B. Diameter is the longest chord of the circle. So only statement B is true, sir.
Okay, first let us have the discussion about statement A. All chords of a circle are diameters. Is it true or false?
False, sir.
Can you explain why?
Sir, because all diameters are chords, sir.
Very good. Every diameter is a chord, but every chord need not be a diameter. But I want to make a chord as a diameter. What is the condition I can imply on it?
Sir, you want to pass through the center, sir.
Very good. A chord passing through the center we can call diameter. Very good. And statement B.
Diameter is the longest chord of the circle. Sir, true.
True. Very good. Just now we discussed as a note point, right?
Yes, sir.
Which option is correct here? We have to choose.
Sir, option B.
Only statement B is true. Very good. Sriyansh, you can mute. So this is the answer we got. That is option B. And next question came in the same year, 2023 paper. Match list 1 with list 2. So on list 1, we have longest chord, space between two radii, half of a circle, half of diameter. On list 2, we have radius, diameter, sector, and semicircle. Who's going to match? Raise a hand if you want to answer. Harini, can you answer this question?
Yes, sir.
Yes, read the terms one by one in list 1.
Sir, the longest chord is diameters.
Wait a minute. Longest chord is diameter. Yes, it is correct. Just now we discussed. So let us write here. A is matched to 2. Next.
Sir, next the space between two radii is sector.
Space between two radii is sector. Yes, it is B connected to 3. Next.
The half of the circle is called semicircle.
Yes, C is 4. Next.
Half of diameter is called radius.
Yes, this is very simple. Which option is giving all the correct answers, Harini?
C.
Is it C?
Yes, sir.
Yes, answer C. Very good, Harini. You can mute now. So just now we discussed the note point. Longest chord is nothing but the diameter, and space between two radii is sector. Half of circle is semicircle, and half of diameter is radius. So this is about circle and its parts. And next one important theorem we are going to discuss, and it is called central angle theorem. So without the proof, let us try to understand it. So there is a circle, and let's say the center is here, and let's take a card. Okay, this is a card A, B, end points are A and B, and let us take a point here. It is C. Okay, and the center we are generally calling O. So the angle formed by this card at the center, to create that angle, we connect the end point to the center and the other end point to the center. We call this as the central angle. What do you call this? Central angle, subtended by the arc. Subtended means formed, that's it. central angle subtended by the arc, and you connect the endpoints of the card with any point other than the minor arc. Like you can take C here, just A to C and C to B. This is called an angle subtended. Subtended means formed, subtended by the same card, by the same, you can say arc also, by the same arc at other part of the circle. What do you mean by other part? Other part means this arc only creating that angle. You cannot take the point on the arc again. Other than the arc, any part of the circle, remaining part you can take, but don't take on the arc. So there is a relation between these two angles, the central angle and the angle subtended by the arc at the other part of the circle. The central angle is always twice. That means 2 times that angle. That means if you take the figure again to draw some angles, so let's take a point A here and a point B here. So this is a center O. Let us take a point C here. Suppose if I know this angle ACB is given something like 40 degrees, then we can say this AOB is going to become 80 degrees because of central angle theorem. What is central angle theorem? The angle subtended by an arc at the center is equal to 2 times the angle subtended by the same arc at any point on the remaining part of the circle. Okay. See, this can be applied on the major arc also. So as the statement we are applying on the minor arc, now the same statement can be applied on the major arc also. See this one. Now the major arc is also an arc. Okay. It is subtending some angle at the center. Where is that? This angle. Okay. So what is this? 360 minus 80. So there are two angles which are sum is going to become 360 complete angle. So 360 minus 80 is going to be 280. So it's going to be 280 degrees. Now, if you take any other point on the remaining part of the circle, let us take this is D. So this angle is going to be half of that angle. So 280 degrees half is going to be 140 degrees. So this is what central angle theorem. Okay. So there is a proof of this, but it is out of your scope. Just remember the statement. What is it? The central angle subtended by any arc is always twice compared to the angle subtended by the same arc at any point on the remaining part of the circle. Okay. So this is central angle theorem, and there is a corollary for this. What do you mean by corollary? Corollary means it is not a new statement. It is the same statement which can be proved from the help of this. Okay. See, what is this corollary? The corollary is you take a circle and this arc. Let us take AB is the arc. Now let us take the center O. I'm taking a point here B, and I'm taking a point here C. Okay. First, I'm sorry, B is already used now. Let us take some other point. I'm taking a point here C, and I'm taking a point here D. Okay, anywhere you can take any 2 points. See, first I'm joining C to A and C to B. Let us say this angle is X. Now, according to the central angle theorem, A is joined to O and O is joined to B. This is going to become 2X because of the central angle theorem. What is it? The angle subtended by the arc at the center is twice the angle subtended by the remaining part of the. So it is X multiplied by 2. It is 2X. Now I'm taking another point on the same remaining part. Now it is a new position D. Connect A to D and connect D to B. This is also going to be X. Why? Because half of 2X is going to be X again. That means this is giving rise to a new statement. What is that? Angles subtended by same arc in the same segment are always equal. So simply we can say angles in the same segment are equal. You can remember that. Okay. That means infinitely many points. Anywhere on the circle you take. Suppose if you take a point here E, join A to E, E to B. This is going to be X. You take a point here F, join A to F, F to B. This is also X. You take a point here G, join A to G and G to B. This is also going to be X. That means angles in the same segment of a circle are equal. So these two statements are very important. So the first statement is called central angle theorem. I repeat again, what is central angle theorem? The angle subtended by an arc at the center is double or twice the angle subtended by the same arc at any point on the remaining part of the circle. And what is corollary? Corollary is simple. Angles in the same segment are equal. So based on this, we are going to solve some questions. But before going to solve questions, any doubts in these two statements you can ask. Any doubts? Amshuman, you have any doubts? Amshuman?
Sir?
Yes, you have any doubt in this?
Sir, yes, sir.
What is that?
Sir, why the central angle is twice of the another angle, sir?
I told you
Sir.
already, it has a proof, but it is out of your scope. Just remember. If you want, I can explain, but we can take it later. It takes time.
Okay, sir.
Okay. So this is about central angle theorem and its corollary, and some other students are having their doubt. Dhanvir, you have any doubt? Dhanvir?
Sir, not understand the sir.
Central angle theorem is, you take, I'm telling you once again, you concentrate now. There is a circle. Okay. I'm taking an arc. AB is one arc. This is the center O. Let's take a point here and say C. If I join A to C and C to B, suppose I have this angle 60 degrees. Okay. Now without measuring anything, you can say that the central angle is going to be 120 degrees. This is central angle theorem. Okay. And that 60 degrees will be common wherever you put point C. If you put point C, here also it's going to be 60 degrees. Here also it's going to be 60 degrees. Everywhere it's going to be 60 degrees on the same part of the circle. That means angles in the same segment are equal and central angle is twice that angle. Both are true.
Sir, why, sir?
You want proof?
Yes, sir.
Okay, let's take proof. If you understand, it's good. Okay, then you can mute. We'll discuss the proof. This is a circle and this is center O. Let's take this point is A and this point is B, and let's take this point is C. I'm just connecting A to C and I'm just connecting C to B. Let's say this point is X. Okay, I'm sorry, this angle is X. Say this angle is X. I'm joining A to O and I'm joining O to B. Okay, we want to prove angle AOB is equal to 2x. That is a proof of this theorem. So what I'm going to do is, I am joining C to O. I'm joining C to O. This is the construction I'm doing. So whenever I join like this, I got two triangles. One is CAO triangle and another one is COB triangle. Okay, so let us concentrate on CAO triangle. We don't know this part, let us say x1. We don't know this part, let us say it is x2. Okay, now which type of triangle is OCA? Which type of triangle is OCA? Anyone will answer? What can you say about the triangle OCA? Anyone? I want the type of the triangle. Who will answer this? Which type of triangle is OCA? Neeraj, can you answer? Neeraj.
Sir?
Which type of triangle is OCA?
Sir, scale and triangle, sir.
No, wrong answer. Check once again. Vishnu, can you answer which type of triangle is OCA?
Sir, it is an obtuse angle triangle.
Not according to the angles I want, according to the sides.
Sir, I think it is isosceles triangle.
Can you say why?
So what did you tell?
Can you say why?
Sir, because the down part is a radius and the Upper part is a radius also.
Very good, excellent answer. So you can see OA is the radius of the circle and OC is the radius of the same circle. We know radii of the same circle are equal. So in OCA triangle, OC equal to OA. So two sides are equal, so we call it is an isosceles triangle. And moreover, Vishnu, in isosceles triangle, you know even any property about angles? We discussed in types of the triangle property. So whenever isosceles triangle is there like this, two sides are equal. I told you opposite angles are equal. Yes, Vishnu? Vishnu, you muted. Okay. So this is the property you have to remember. That is, in an isosceles triangle, whenever two sides are equal, their opposite angles are going to become equal. So here if it is x1, this is also going to be x1. Okay. And similarly, in the triangle OCB, okay, I want to find again OC is equal to OB. Okay, if two sides are equal, their opposite angles are going to become equal. If that is x2, and this is going to become x2. Now, I want to find the central angle now. What I do is, let us extend this CO connection further. Okay, now what I'm getting is, we can find this angle in the triangle OCA. So this is the exterior angle, which is equal to its sum of interior opposite angles we discussed in triangle chapter. Whenever we have a triangle, extend one side. Exterior angle is equal to sum of its interior opposite angles, these two. Why is that true also very important? Very simple. We can say the sum of interior angles is 180 degrees and the exterior angle and this interior angle is also 180 degrees. The common thing gets cancelled and we get exterior angle is equal to sum of its interior opposite angles. So using that property, this is going to become 2x1. x1 plus x1 is going to become 2x1. Similarly, in this triangle COB, x2 and x2 if you are going to add, it's going to become 2x2. Therefore, we got angle ACB is x1 plus x2, which is nothing but x. Angle AOB is nothing but 2x1 plus 2x2. You can take 2 common, that is 2 of x1 plus x2. But x1 plus x2, we know it is x. So finally we got proved it is 2x. That means central angle is always twice the angle subtended at remaining part of the circle. That is the proof of central angle theorem. So if central angle theorem is proved and angles in the same segment of circle are also same, because 2x is equal to 2y, 2 gets cancelled and x is equal to y. So any other doubts left, you can ask, and then we'll move to the problems based on this theorem or the property. Abhyuday, you have any doubts? Abhyuday?
Sir,
Yes, Abhyuday.
sir, I didn't understand this.
See, in your geometry proofs are not required, only the properties are important. Even if you don't understand, no problem. But you just remember, central angle is 2 times the angle subtended at the other part of the circle. That's it.
So not sir, x1 plus x. That what?
See, x is divided into 2 parts. We called x1 and x2, right? So x1 plus x2 is going to become x, right?
Yes, sir.
2x1 plus 2x2, I can take 2 common, 2 into x1 plus x2. But x1 plus x2 already we called x. So AOB became 2x, right? So central angle is 2 times the other angle.
Yes, sir.
Okay, now let's solve some questions based on this. So remember these two statements important in solving some questions. Okay, like this question in 2021 exam. The angle subtended by the diameter of a circle on any point on the circle is. Okay, who is going to answer this? Interested students can raise a hand to answer this question. Danveer, can you read the question? Danveer.
The angle is augmented by the diameter of the semicircle. Any point of the circle is.
Yes. First, shall I help you by drawing a figure?
Yes, sir.
So there is a circle, and this is the center, and this is the diameter. They're asking the angle subtended by the diameter of semicircle at any point on the circle. Let's take a point here and say it is A, and let's take these 2 points are X and Y, okay, the endpoints of the diameter. So the diameter endpoints are connected to the any point on the circle, you can take anywhere. So they're asking this angle, XAY, what is this angle?
Sir, it
What is
was
this angle?
obtuse angle, sir.
I'm not asking type of the angle. What is the measure of that angle?
Sir, 90.
Why 90?
Sir, it was straight angle, sir.
Straight angle not 90. Straight angle is 180.
Sir, it was right angle, sir.
Why right angle? Because it looks like right angle, you cannot answer. You have to explain why it is 90 degrees. Who will give me the reason why? Yeah, the answer is correct. Angle XAY is 90 degrees. But I want the reason why it is 90 degrees. Who is going to answer? Rishika, can you answer this? Rishika, why angle XAY is 90 degrees? Amshuman, can you answer?
Sir?
Why XAY is 90 degrees?
Sir, because of diameter causes 180 degrees, sir.
Okay.
Sir, this XAY angle is half of the central angle, sir.
Very good. Excellent answer. So diameter is a straight line. So this angle is going to become 180 degrees. And the other part is half of that. If central angle is twice, the other angle should be half. What is half of 180 degrees? It is 90 degrees. So this answer is based on the central angle theorem. And the answer is C. That is 90 degrees. Very good, Amshuman. You can mute. So the answer is 90 degrees. So this is about central angle theorem and the application. And now one simple topic is left in geometry, that is symmetry. Okay, symmetry, as you can see, for example, I have a kite. Kite, just now we discussed today a type of quadrilateral where this are equal, this are equal. That is, two pairs of adjacent sides are equal. It is a kite. If you take a kite, okay, and you take the vertical line, this imaginary line, is it dividing the figure into two identical parts on both left side and right side? Yes. So this is called line of symmetry. This is called line of symmetry. Okay. And how many parts are there here? Two parts, and these two are superimposed on each other, either left part coming over right or right coming over the left. You cannot identify whether there are two parts or not. They are acting as the mirror image of each other. So this is about the symmetry, very simple. And you have some different figures to answer. For example, there is a square and you have to answer how many lines of symmetry are there for square. You can see this is a line of symmetry, both sides are equal. You can see this is a line of symmetry, both top part and bottom part are equal. And you can see this is a line of symmetry. And um, if you fold that paper, if the paper is in square shape, if you fold along that dotted line, then they will be superimposed on each other. So that is also a line of symmetry, and this is also a line of symmetry. So like that, how many are possible? Four lines of symmetry are possible for a square. And for so kite we have only one. Kite we have one. Square we have four. And let us take rhombus. So rhombus, how many are possible? We have a line of symmetry here and we have a line of symmetry here. That's it. So we have exactly two lines of symmetry. Let's take an isosceles triangle. In isosceles triangle where these two are equal, we have only one line of symmetry. So one line of symmetry like this. For different figures, you have to identify which is the line of symmetry and how many lines of symmetry are there. We are going to identify. Okay. And whenever a figure is having at least one line of symmetry, we say that the figure is symmetrical along that line of symmetry. Okay, now before we solve the questions based on this concept, any doubts in this symmetry and line of symmetry? Dhanvir, any doubts?
Sir, cannot hear your voice, sir.
Dhanvir, am I audible?
Yes, sir.
Any doubts in symmetry you have?
No, sir.
Amshuman, you have any doubts?
Sir,
Yes.
sir, I have doubt that equilateral triangle also have only one line of symmetry.
You tell me the answer. Equilateral triangle will have how many lines of symmetry?
Sir,
Yes, tell me. How many?
sir, sir, one.
Not one. More than one.
Sir, how, sir?
This is one line of symmetry, no?
Yes, sir.
Is this also a line of symmetry?
Sir, why, sir?
Yeah, it is equilateral. It is symmetrical along all the three sides. You take any equilateral triangle and try to fold along three lines of symmetry. Every time it matches. Three
Okay,
lines.
sir.
Okay. So
Okay, sir.
equilateral triangle is going to be three. Okay. Let's write the names of the figures also. This is kite. For square we have 4, and for isosceles triangle we have 1. Isosceles triangle we have 1, and rhombus we have 2, and equilateral triangle we have 3. Like that, for many other figures we can discuss. Okay, so this is about symmetry and line of symmetry, and yes, let's try to solve the questions based on that. So 2022 exam you got this question. Okay, which one of the following figures is not symmetrical along the dotted line? Who is going to answer this?
Sir, can I answer this?
I'm sorry, solution I already displayed, but no problem, you can explain about it. Option A, symmetrical or not?
Sir, yes, sir.
Yes. Can you explain why it is symmetrical along that line?
Sir, because of left side part is sir, mirror image of right side part.
What about B? Is it a line of symmetry?
Sir, yes, sir.
What about C?
Sir, no.
So this is yes, this is yes, this is no. What about D?
Sir, yes.
Yes. So it is option C. Very simple, right? So it is option C. So this is about symmetry and line of symmetry, and many more questions can be solved. So this is about geometry, as we have discussed, and moving to mensuration, we have perimeter and area. Okay, let's go one by one. So starting from square, let us start from square. So we discussed all the properties of a square. Okay, so in square all the sides are equal, or every angle is right angle, and etc. Let us say one side is S. First I want the perimeter. Perimeter means the length of the boundary. If this is yes, this is yes, this is yes, this is yes. So length of the boundary is S plus S plus S plus S. 4 times S. I can write 4 into S. So perimeter of a square is 4 into S. And area. Area of a square is defined as, so first of all, what is 1 square centimeter? The area of a square having each side 1 centimeter is called 1 square centimeter. By following the definition, you can say area of the square is going to be side into side, or you can say side square. Okay, this is about perimeter and area of a square. And not only this, we need to check the relation between side and diagonal. I told you many times in class. Let us say this is diagonal and denoted by D. So this is a right angle triangle, because in square every angle is the right angle. You know which type of triangle is this? Who will answer? The shaded triangle is which type of triangle? Harini, can you answer? Which type of triangle is that?
Sir,
Harini, which type of triangle is that? Which one I shaded?
sir, right angle triangle.
Which is right angle triangle. Moreover,
Sir,
other than right angle, it's also having one more type name.
sir, isosceles.
Yeah, together can we call right isosceles triangle?
Sir, scalene.
Is it a right isosceles triangle or not?
Sir, no, sir, right. Sir, right scalene triangle.
Why you write scalar? It is right as well as side equal, no?
Yes, sir.
Yes. Because it is a right angle triangle, can I use the Pythagoras theorem?
Yes, sir.
By using Pythagoras theorem, what is the equation that I can write using D, yes, yes? Can you tell me?
Sir, sir,
Yes, tell me.
sir, d square equals to
Yes.
s square plus s square.
Okay. Now I want D in terms of yes. So D square is equal to 2s square. I can write
Yes,
transpose square to the other side. We get root
root
2s
yes,
square, and it's finally going to give D is equal to root 2 times yes, right?
yes, sir.
The next property about diagonal and side of a square. So first of all, perimeter of a square is 4 times side. Area of a square is side into side or side square, and diagonal of a square is root 2 times of the side. So if you know side, just multiply by root 2, you'll get the diagonal. So this is about square formulas. And rectangle. So rectangle, we have 2 dimensions. Let us say this is L and this is B. Okay. Now let us discuss about perimeter, area, and as well as the diameter. Sorry, diagonal. Now, perimeter. In rectangle, opposite sides are equal. This is L, this is also L. If this is B, this is also B. So length of the boundary is called the perimeter. L plus B plus L plus B. So L plus B repeated twice. So I can write 2 times L plus B. So this is the perimeter of the rectangle. Now area of the rectangle is length multiplied by the breadth. Okay. You can divide into so many smaller squares and you can find the area. The formula is going to be length into breadth. And I want the diagonal of this rectangle. Diagonal, let us call it D. So who will tell me the relation between D, L and B? Who is going to answer? What is the relationship between diagonal, length and breadth of a square? Who is going to answer? Raise the hand if you want to answer. Abhyuday, can you say the answer? What is the relationship between diagonal, length and breadth?
Sir,
What is the relationship between diagonal, length and breadth?
sir, no, sir, I have a doubt.
What is your doubt?
Sir, in symmetry, circle has how many symmetry lines, sir?
You can answer on your own. You tell me, how many lines of symmetry do you think a circle? Abhiday,
Sir, infinite.
yeah, infinite is correct. Any line you draw through the center, it makes the circle into two equal parts, no? So that it's a good question, and the answer is infinite. Okay. And Vishnu, can you answer what is the relationship between the diagonal, length, and breadth of a rectangle?
The square root of L square plus breadth square is equal to diagonal.
Can you derive that?
Sir?
Can you derive that? What is the proof?
Sir,
You can use which
Py-
theorem?
the Pythagoras theorem.
Yes, Pythagoras theorem. So we can write d square is equal to L square plus B square. Now I want the d value. What can I do?
Sir, d square.
Transpose square to the other side, you get the required answer.
Sir, then square root L square plus breadth square.
Yeah, that's it. So we got perimeter of a rectangle is 2 into L plus B. Area of a rectangle is length into breadth. And diagonal of a rectangle is square root of L square plus B square. So all these three are useful. And next we have, after square and rectangle, let's take parallelogram. So parallelogram we discussed already in the types of quadrilaterals and properties. Let us say this is A and this is B. We know in parallelogram opposite sides are parallel. If this is A, this is A. If this is B, this is B. So perimeter is very simple. We can add all of them. A plus B plus A plus B. So this A plus B repeated twice. So it's nothing but 2 times A plus B. So it is same as rectangle perimeter only, but there we call breadth and height, length and breadth. But here we don't call length and breadth. We only call side A, side B. Next, area. Area of a parallelogram can be put, that is base multiplied by the height. Okay, you can take any side as the base. If you want to take B so that it is base, you can write here A, B, A, B. You can even take A as the base, no problem. So the perpendicular distance between these two parallel sides, let us call it H. Okay. Now the area of the parallelogram is given base into height. Okay. But be careful, if you take this side as the base, now you want this height, that is called corresponding height. For every base, you have to take the corresponding height, not the any height. If you take this A, now you cannot use this height to find the answer. You have to use this height to find the answer. That means the height should be corresponding to the base. Whichever line is drawn perpendicular onto it, then that is called the corresponding height. So it's simply not base into height, it is base into corresponding height that you have to say. So this is perimeter and area of parallelogram. Perimeter is 2 into A plus B and area is base into height. Next, let us discuss about trapezium. So let's take a trapezium. Let's take this is A, B, C, and D. So perimeter is very simple. That is sum of all the sides, A plus, B plus, C plus, D. And area. If you take the perpendicular distance between these two parallel sides, we know these two are parallel row. So this is H. Now to get the area, what you do, we divide the trapezium into two triangles. Okay. The top triangle area is going to be half into base into height. A I took as base and H is the corresponding height. And the bottom triangle, the base is C and height is H. So we can take half into A plus C into H. I took half common and H common. So it's nothing but half into sum of the parallel sides and perpendicular distance between them. That is the formula for area of the trapezium. So area of perimeter of the trapezium is sum of all the sides, and area of the trapezium is half into sum of the parallel sides into the perpendicular distance between them. That is the trapezium, perimeter and area. Next, let us take a normal quadrilateral. Normal quadrilateral means we don't know anything about the quadrilateral other than it's having 4 sides. That's it. So how to find the perimeter area in that case? So let's take a normal quadrilateral. So we know only it has 4 sides and no other property we know. Let us take the sides are A, B, C and D. Perimeter is very simple, length of the boundary, that is A plus, B plus, C plus, D. But I want the area. Then what I do is, you take any diagonal, your wish. I'm taking this diagonal. You can even take this diagonal, no problem. You'll get same answer. I'm taking this diagonal and let us draw the heights onto this diagonal. For example, if I draw from this vertex, let us say this is H1. If I draw from this vertex, let us say this is H2. So what is the area of the left side triangle? It is half into, let us say this diagonal is D1, half into base into height. What is other triangle? Half into base into height. You can take that common. Half into D1 you can take common, that is H1 plus H2. So this is the area of quadrilateral. Even if you take D2, you'll get the same answer. That means similar type of quadrilateral you take. I have taken this diagonal, no? In place of that diagonal, even if you take this diagonal, find this as H1 and this as H2 and apply the same type of formula. you'll be getting the same area. Final answer is going to be same. Okay, so perimeter of the quadrilateral is sum of all the sides a plus b plus c plus d, and area of the quadrilateral is this one, half into d1 into h1 plus h2. So d1 means one diagonal, and h1 and h2 means the heights drawn onto the diagonal. And next we take triangle. Triangle is very, very important. Let's take a triangle, normal triangle. We don't know anything about it, whether it is isosceles, equilateral, nothing. Right angle, nothing we know, only triangle. Let us say this side is A, this side is B, and this side is C. So we know the perimeter is length of the boundary, that is A plus B plus C. And area. To find the area, we can say that if this is the base, okay, we have to draw the corresponding height onto that base only. Let us say this is H. For example, if you want to use C as the base, then you have to draw height onto that part or that side. If you want to take A as the base, then you have to draw the height onto A. That means whichever base you select, you have to draw the height onto that base only. So the area of the triangle is going to be half into base into height, and moreover it is corresponding height. The H is corresponding to this base, so we will get the correct answer. So half into base into corresponding height. And we have one more formula to calculate area of the triangle, that is called Heron's formula. That is called Heron's formula. So in Heron's formula, if you want to find the area of the triangle, first you should find the semi-perimeter. Semi-perimeter means what? That is half of the perimeter. Perimeter, we already know that is A plus B plus C. In that half, we know perimeter is already A plus B plus C, that is 2. That we call it S. So S means what? Semi-perimeter. Its value is A plus B plus C by 2. Then after finding the semi-perimeter, now you can find the area of the triangle. Area of the triangle is many times represented by delta. So it's going to be square root of S into S minus A into S minus B into S minus C. So using this formula also we can find the area of the triangle. So semi-perimeter is A plus B plus C by 2. And once you get the value of S, then you can find the area of the triangle using square root of S into S minus A into S minus B into S minus C. So any doubts still here you can ask. So next, so many figures are there we are going to take tomorrow. Amshuman, you have any doubts?
Sir?
Do you have any doubts still here?
Sir, yes, sir. Sir, why you take? Sir, why that formula is used?
To find the area of the triangle when height is not given, only all the three sides are given A, B, C. Then we can find the area of the triangle using this formula.
Sir, we can also find height and we can use the formula half into base into height.
But height we cannot find if you don't have any clues with the sides, right? Then without finding height also we can find you area using Heron's formula.
Okay, sir.
Harshavardhan, what is your doubt? Harshavardhan? Harshavardhan, you are not audible. Okay, students, we have more figures and their perimeter area formula, and after that we are going to discuss volume and surface area also. So whatever figures we discussed today in geometry and as well as mensuration, we discussed in geometry so many types of triangles, quadrilaterals, their properties, and the related questions. And even in mensuration also, perimeter and area we discussed, and more figures are left. We are going to take tomorrow. But as of now, I'm stopping the class here. You need to revise all these and come. So without revising the formulas, you cannot solve the questions and you cannot identify the next clues also to answer the questions. So revise all these and come for tomorrow's class. Okay. So that's it, students. You may leave the class now. Thank you for joining, all of you.